In some instances, we may want to create new composite variables from the data within our data frame. In other instances, we may want to collapse categories within some of our categorical variables, as these processes can often lead to some meaningful insights. Let's first think back to our SE processed no piano keyboard data frame. In order to create that data frame, we ended up removing rows of data for all of the people who responded piano keyboard as their instrument. And in this case, we removed 17 rows of data from our original SE process data frame. One thing we also could have done is created a composite variable from the instrument variable. And that composite variable could be a logical variable, indicating either true, the person plays piano keyboard, or false, the person does not play piano keyboard. And we can use that composite variable for some further analyses. So in order to change this categorical variable to a logical variable, let's create a new object. We'll call it piano keyboard. Now the first thing we want to do is call on the instrument variable within our SE process data frame. So SE processed, we'll use the $ notation, and we'll call on instrument. And then what we can specify is exactly equal to piano keyboard, which is the response category. So is exactly equal to piano keyboard. Let's run this code. And if we print this to the console, we see that for every instance where the person responded piano keyboard, it's indicated as true. And for all other respondents, it's indicated as false. Another thing we may want to do within our data is collapse categories. So if we remember back from our SE process data frame, item 1, item 2, and item 3 are ordered factor vectors with 4 levels of responses: strongly disagree, disagree, agree, and strongly agree. With the 4-point Likert type response format, there are 2 categories that have a disagreement sentiment. And then there are 2 categories that have an agreement sentiment. So one thing we may want to do is collapse strongly disagree and disagree into one category, and collapse agree and strongly agree into another category. So what we would be doing here is collapsing our polytomous response categories into dichotomous response categories. So in order to do that, we can use a library to help us, and the library is Plier. I already have it installed on my computer, so I'm going to load it using the library function. And from the Plier package, we're going to use the revalue function. So for our example, let's work on item 1. Let's first create a new object. We'll call it item 1 dichotomous. We're going to use the revalue function from the Plier package. First, we'll specify the variable that we're working on. So SE processed, item 1. And then from here, we're going to use the concatenation function, and we're going to specify what we want the new categories of responses to be. So in this case, we want to collapse strongly disagree and disagree, and then we want to collapse agree and strongly agree. So let's call them just disagree and agree. So within double quotes, we'll take our strongly disagree category, and we're going to change it to disagree. We'll separate it with a comma. And now let's do our next category. We're going to take our disagree category, and we're going to keep it the same, and we're still going to call it disagree. Next, we're going to take our agree category, and we're going to keep it the same, and we're going to call it agree. And then last, we want to take our strongly agree category, and we want to change it to agree. We'll run the code. And now if we print this to the console, we'll only see agrees and disagrees. Now, although we lose information in this context, sometimes the collapsing of categories can provide more meaningful insights. One thing we may want to do is collapse numeric variables into categorical variables. Again, we lose information here, but sometimes it can be meaningful when we're exploring the data. So for our example, let's say we want to take our child age variable and we want to break it up into 3 groups. So rather than thinking about just the age of the students, maybe we want to think of them in the context of elementary school students, middle school students, and high school students. So in order to divide the data, we need to use the cut function, and we need to specify where we want our breaks using a breaks argument. And so let's say the elementary school students are ages 7 through 10. The middle school students are ages 11 to 13, and the high school students are ages 14 to 17. Before we start, let's take a look at the range of our variable. We see that the lowest value is 7 and the highest value is 17. So when we create our breaks, we need to include 7 and 17. So essentially, we need to start and end our breaks with the value below the lowest and above the highest. For now, that's probably the safest way to play it. So in this case, we want to set our breaks to 6, 11, 13, and 18. So 6 to 11 will be our first category. 11 to 13 will be our second category. And then 13 to 18 will be our third category. Now, one problem is that the age levels can overlap. So students that are age 11, for example, can be assigned to either elementary school or middle school. Similarly, children that are age 13 can be assigned to either middle school or high school. So one important consideration that we need to make is what category to assign to the overlapping numeric data. In this case, we're going to assign age 11 to elementary school and age 13 to middle school. We're not going to talk about it here in the video, but we need to think about using either brackets or parentheses to either include or exclude adjacent categories. Inclusion or open is usually defined by a parenthesis, and then closed or excluded is usually defined by a bracket. Again, here we're not going to talk about that specifically, but just keep that in mind as you work. So let's set our breaks in a new object. We'll call the new object breaks. We'll use the concatenation function, and we'll specify 6, 11, 13, and 18. Okay, so let's now create a new object to create the variable. We'll call the object child age, categorical, and we're going to use the cut function. First, we'll specify the variable we're working on. So SE processed child age. Here we're going to have a meaningful monotonic ordering. So here we need to create an ordered factor vector. So let's set ordered to true. Here we'll use the breaks argument to set our breaks. We'll use the concatenation feature again. 6, 11, 13, and 18. Now we could just write breaks equals breaks because we already stored the concatenation in an object called breaks. But for good measure, we'll just type it out again here. And then last, we want to create our labels. So let me break the code so it'll be easier to read. So the labels, we'll use the concatenation feature. Our first label will be elementary. The second category will be middle. And the third category will be high. Okay, let's run this code. And now if we print it to the console, we'll see that we have all of our categories, either elementary, middle, or high school. And it's an order factor vector by looking at the levels. So now that we've created these new variables, one thing we may want to do is append them to our data frame. And so there are 3 methods for doing this. First, we can use $sign notation. Second, we can use bracket notation. And third, we can use the cbind function. So let's say that we want to add our piano keyboard vector to our SE process data frame. The first method we can use is $sign notation. So first, let's specify the data frame that we're going to use, which is SE processed. We'll use the $sign notation. And after the $sign notation, we want to specify what we want to name our variable within the data frame. Let's call it PK for piano keyboard logical. And then we'll use the gets operator to make the assignment. And then we want to assign the vector that we've created. So the vector is called piano keyboard. Let's run the code. And we see here in the global environment that we've added the PK logical vector to the data frame, and we now have 7 variables. And we can also double check this by using the names function. And we see here that PK logical is appended to the data frame. Okay, the next method we could use is bracket notation. So it's a similar process. Let's first identify the data frame that we're working on, which is SE processed. And then here, instead of using $sign notation, we'll use the bracket notation. And then within double quotes, we'll specify what name we want to use for the variable within the data frame. So here, let's do PK logical. And just to recognize it a little easier within our work here, we'll just call it PK logical 2. We'll use the get symbol to make the assignment. And then again, we'll identify the variable that we want to append. So here, piano keyboard. If we run the code, we'll see that the variable PK logical 2 has been added to the SE process data frame. And now we have 8 variables. And then the last way to do this is we can use the columbine function. So let's first specify the data frame that we want to use. We'll use the get symbol for the assignment. Now here we'll use the cbind function, which stands for column bind. We'll again identify the data frame that we want to use. So SE processed. We'll specify the name of the variable that we want to use within the data frame. So here we'll call it PK logical 3. Use the equal sign, and then we want to specify the vector we want to append. So here it's piano keyboard. We'll run the code. And we see here in the global environment that we've added PK logical 3 to the data frame, and we now have 9 variables. Now, in order to remove a variable from a data frame, we can use the within function. Let's remove PK logical 2, and then we'll remove PK logical 3. So let's specify the data frame we're working on. We'll use the within function, and within SE processed, we want to use the remove function, and then we can remove whatever variables we'd like. Here, let's remove PK logical 3. And we'll also remove PK logical 2. Let's run the code. And we'll see now we're back to 7 variables in the data frame. Now, one thing we may want to do is reorder the variables once we've appended them. So by default, any variable we append to a data frame is going to be added on at the end of the data frame. However, if we're thinking about the structure of our data frame, we see that we have our demographic variables first, so years participating, child age, and instrument. And then we have our Likert type responses second, so item 1, item 2, item 3. So what we may want to consider doing here is moving the PK logical variable after the instrument variable. So that way the 2 instrument variables are together and then all of the demographic variables are together. So in order to accomplish this, let's use an indexing procedure. Let's call in the data frame we're working on, which is SE processed. Again, we'll specify the data frame. We'll use bracket notation. Now again, if we remember from previous videos, when we're working with bracket notation, we always think about two values, x and y. X refers to the rows, y refers to the columns. So in this case, we want to retain all of our rows. So we're going to leave the rows blank. And then now we want to change the order of the columns. So we'll use the concatenation function. And now we can either specify it using the position of the variable or the name of the variable. Let's specify the position of the variable. We want to keep years participating, which is in position 1, child age, which is in position 2, and instrument, which is in position 3, the same. So here, we'll specify that we want 1 through 3 to be the same. Next, we want to position our PK logical variable. It's currently in position 7, so here we'll identify position 7. And then item 1 through item 3, which is in position 4 through 6, we want to list those next. So 4 through 6. If we run the code, we see that the ordering is now changed in the global environment.